Hi everyone, this is Preeti Pandey. Welcome you to my channel, Miss P2 Chemistry. See guys, today I'm speaking English and from today onwards I'll take the lectures always in English because I know there is no response going in my channel, so I'll upload as I like. So today I'm going to start carbon and its compound. This is chapter number 4 as I have completed 3 chapters of class 10. So this is the chapter number 4, and for third chapter I have also completed all the NCERT exercise questions and also the in-text questions. Okay, so let's start carbon and its compound. See, this chapter is not small like other chapters I have completed so far, like first, second, and third chapters. This is a little bit lengthy chapter, and it is also it also forms the basis of class 11th and 12th. This you can say this is the foundation of class 11th and 12th organic chemistry part. Okay, let's start carbon and its compound. See, occurrence of carbon. We are going to study about occurrence of carbon. We will start from occurrence of carbon. See, first, if somebody asks you that what is carbon, what will you give an answer? Okay, so what will you say? What is carbon? See, I have told you as in previous chapters, metal and its compound just before this chapter, that is chapter number 3. There I have explained what is carbon. Carbon is basically, actually my headline is also red and this one is also red, so I'll select some other pen. Black would be better, red is given. Yeah, this one is better. So, what is carbon? As I have told you, carbon is a non-metal. Carbon is a non-metal. Okay, guys, this is not so thick. Let me choose another one in color. Yeah, I can take in color. In color, okay, black. Yeah, it is of the same strength. I want a much thicker pen, much thicker, much thicker. It's okay. Let's do from this. Okay. So what is carbon? We know that carbon is a non-metal, and this non-metal belongs to P block. Okay, this belongs to P block. Okay. Now, if somebody asks you what is carbon, you can easily tell that this is non-metal. And we have also studied the properties of non-metal, its physical and chemical properties as well. Okay, so if you guys haven't read or seen or watched that chapter, you can visit my channel, and I have completed whole chapter with the NCERT exercises as well. You can visit. Okay, guys. So let's start this chapter. Let's start from the first point. Carbon is found in the atmosphere, inside the Earth's crust, and in all living organisms. See, carbon is found in the atmosphere. It is saying that carbon is generally found where? In Earth, in atmosphere, inside the Earth's crust, and in living organism, and also in living organism. Living organism means in humans also. In humans, in living organism, we mean in humans, in animals. Carbon is found in animals, in humans also. Okay. Okay. Now read the second point. Carbon is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas, etc. See, the element carbon found in atmosphere, in what form it is present. See, what forms it is present. It is found in form of wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas, etc. Okay, read the point third. Carbon is present in compounds like carbonate. Carbon is also found in nature or in compounds in the form of carbonates. What is carbonate? Carbonate is a chemical compound whose formula is CO3 2 negative. Whose formula is CO3 2 negative. Okay, hydrogen carbonates, etc. Hydrogen carbonate is HCO3 2 negative. Okay. Carbonate and hydrogen carbonate, the only difference is the presence of hydrogen in hydrogen carbonate. and absence of hydrogen in carbonate. Okay, now read the fourth point. Carbon is found in free state as diamond, graphite, fullerene, etc. I have told you in previous chapter that carbon in nature has three allotropes. Okay, three allotropes are most famous allotropes are diamond, graphite, and fullerene. I have told you and also taught you in very brief about fullerene. That scientist name was fullerene, so it is named as fullerene. Okay, Buckminster fullerene. See, carbon is found. See these pictures. You can easily see that carbon is present in wood also, in coal also, here it is a form of coal, like this is an example of an alloy. You can see steel. In steel some amount of carbon is also present. You can see cylinders. The gas filled in the cylinder also contains the percentage of carbon, like you can say methane gas. That is CH4, sorry, CH4. Okay, or C2, CH4, or you can say ethane also. So, in gas cylinder, carbon is also found in gases. The percentage of carbon is also found in gases as well. Okay, you can see water here or well, or you can see this one. Sorry, you can see this motor pipe. This is motor pipe. It also contains, motor pipe is made of plastic. So plastic has percentage of carbon. Okay, plastic is made from ethene. Okay, plastic is made from ethene. You will read this in class 11th in polymer chapter as well. Diamond also contains percentage of carbon, and diamond is the best example of carbon. As you know, the diamond is the hardest material found in earth. Okay, so I'll just go to the next slide. That is slide number 2. Read it. Carbon and bonding in carbon covalent compound. And now we are going to study about carbon, that what nature carbon causes for its binding. As you know that electronic configuration of carbon is carbon has atomic number 6. So what is its electronic configuration? You can um, divide its electron like 2 electron in K shell and 4 electron in Kl shell. Okay, so in the next shell there are only 4 electrons. Now here's a situation in carbon that we need for the stability of carbon we need 4 electrons. As we know that stable compound contains a configuration like 2-8. We can see this is an example of helium, neon. This is an example of neon configuration. This is neon configuration, and neon is the inert gas. As we know, it does not react. Okay, so we need this configuration for carbon too, or how can we say it is stable if it attains helium configuration? If it attains helium configuration, now to make carbon a stable element, either carbon can donate all its 4 electron. It is not possible for carbon to donate all its 4 electron. Why? Why? If somebody asks you to make carbon stable like helium, can we donate all the 4 electrons that is present in N shell of the carbon? No, we cannot. We cannot, because all the 4 electrons, see, all the 4 electrons, carbon says that it has 6 electrons in the sorry, 6 protons in the nucleus and 6 electrons revolving around. Okay, 2 electrons here and 4 electrons here. So carbon says I have 6 protons in my nucleus. If you donate all my 4 electrons from my outermost shell, I'll become highly unstable, and it is not possible because for stability it needs more 4 electrons. Okay, and there is a possibility that if you want to make carbon a stable species, carbon says if you say that we can give 4 electrons to carbon, we can give 4 electrons to carbon. See, it has 4 electrons in the outermost shell. We can provide 4 electrons to carbon, but here is a condition. Here is a condition that it says if you give me 4 electrons, if you give me 4 electrons, my octet will be completed. Carbon says if you give me 4 electrons in the outermost shell, 1, 2, 3, 4. Let's say we give 4 electrons to carbon in the outermost shell. Now count all the electrons of carbon. It will be total 4, 4, 8 plus 2. It will be 10 electrons. Okay. And now there are only 6 protons. There are only 6 protons. And this is highly unstable condition. So here is a situation. Carbon says I can share electrons. From here there comes a concept of covalent bond. Let's do the sharing. Carbon talks to another carbon and says, let's do the sharing. I have 4 electrons. You have 4 electrons in your outermost shell. Let's share. Let's share our all electrons. So they started sharing, and here 4 electrons are shared between both the carbon atoms and they become very stable. Okay. Now read this concept. You have understood the concept. Now read this para. The atomic number of carbon is 6. As you know, the atomic number of carbon is 6. Its electronic configuration is 2, 4. It has 4 valence electrons. It can attain stability by gaining 4 electrons. As I have said that it needs only 4 electrons in its outermost shell. See here. It needs only 4 electrons in its outermost shell. It needs only 4 electrons in its outermost shell. See here, the condition is it can attain stability by gaining 4 electrons or by losing 4 electrons or sharing 4 electrons with other atoms. So here is the situation that carbon finds it very convenient that it can share its electrons with one another. It does not, see here the condition is it does not gain 4 electrons because it is difficult for the 6 protons to hold 10 electrons. It is the reason. This is the reason why carbon do not gain 4 electrons. Because as I have said, carbon has 6 protons. 6 protons in the nucleus, and if it gains, suppose it gains 4 electrons, it will be highly unstable. It will be highly, you can say it will be highly unequal. For the 6 protons, they will feel very loaded with the negative charge. Okay, so it will be highly unstable for the electrons, for the protons to gain extra 4 electrons. That is why. Understood? See the next point. It does not lose 4 electrons. Also, there is a condition that you cannot lose all the 4 electrons of the carbon from its outermost shell. It needs a large amount of energy to lose 4 electrons. Okay, here is the reason. Note this point and learn it. Why carbon cannot lose all its electrons from its valence shell. Valence shell is the outermost shell where the valence electrons are present. Okay, what is the valence shell? If somebody asks you what is valence shell, you can simply say valence shell is the outermost shell. Valence shell is the outermost shell where electrons are present. Okay, so the electrons present in the outermost shell are called valence electron. Got it? So here is the reason that carbon cannot lose all its 4 electrons because it needs a large amount of energy. To lose 4 electrons. So it shares 4 electrons with other atoms to attain stability, resulting in the formation of covalent bond. This is the reason. Okay, now point it. Now note this point. Make a note for this point. Okay. Since the carbon atom needs 4 electrons to attain stability, its valency is 4 and it is tetravalent. Okay, Got it? If somebody asks you, carbon is a tetravalent species, what will you say? It is a tetravalent species because carbon atom needs 4 electrons to attain stability. Its valency is 4 and it is tetravalent. Okay, carbon is a tetravalent species. You can simply answer. Here is the answer. This is the answer. Why carbon is called a tetravalent species? Because carbon atom needs 4 electrons to attain stability. Its valency is 4 and it is tetravalent. Got it? Move to the next slide. 3. Formation of covalent bonds. Covalent bond is a chemical bond formed by the sharing of electrons. If somebody asks you what is covalent bond, what is covalent bond? If in an examination it is asked define covalent bond, what will you say? Sharing of electrons between atoms is called covalent bond. The sharing of one pair of electrons resulting in the formation of a single covalent bond, sharing two pairs of electrons results in the formation of double covalent bond, and sharing of three pairs of electrons results in the formation of triple covalent bond. Understood? If you share one pair of electrons, it is called single covalent bond. It is called single covalent bond. If you share two pairs of electrons, it is called double covalent bonds. It is called double covalent bonds. If you share three pairs of electrons, it is called triple covalent bond. It is called triple covalent bond. Understood? Now read the example. Formation of single covalent bond in hydrogen molecule H2. The atomic number of hydrogen is 1. Its electronic arrangement is 1. It has one valence electron. It needs one electron to attain stability. So hydrogen atoms share one pair of electrons resulting in the formation of a single covalent bond in hydrogen molecule. How H2 molecule is formed? H2 molecule is the best example of covalent compound. If I ask you, give me an example of covalent compound, what will you say? H2. It is the simplest molecule. It is the simplest example. You can say simplest molecule also. It is the simplest example of covalent bond. See, hydrogen has one electron. Okay, and the other hydrogen also has one electron. This hydrogen needs only one electron to gain stability. This hydrogen needs one electron to gain stability. So they decided to share. Their electron is with them. This electron is not lost. Okay, this electron is not lost. But also this hydrogen H1 gets this electron too, and H2 gets this electron too. Hence it is shared like this. H1 has one electron and H2 has one electron. They share their electrons. See, so this hydrogen too have two electrons, and this hydrogen too have two electrons. Okay, so now both are stable. We know how stability are. All 18 group elements are stable. You know, and hydrogen. See, and if somebody attains the configuration like 18 group elements, so they are also called stable. Okay, so hydrogen got configuration like helium. Helium has configuration 2. So hydrogen also has now configuration 2. So it becomes stable. Now formation of double covalent compound in oxygen molecule O2. This is good example. This is O2, as O2 has 8 electrons and 8 protons. Okay, now we are going to study about oxygen. The atomic number of oxygen is 8, electronic configuration 2 and 6. It has 6 valence electrons. You know what are valence electrons? The electrons present in outermost shell are called valence electrons. Okay, it needs 2 electrons to it needs 2 more electrons to gain stability. So 2 oxygen atoms share 2 electrons of oxygen, 2 pairs of electrons, resulting in the formation of a double covalent compound. Okay, resulting in the formation of double covalent bond in oxygen molecule O2. See, now oxygen has 1, 2, 3, 4, 5, 6 electrons. This has 1, 2, 3, 4, 5, 6 electrons. It only needs 2 electrons. It only needs 2 electrons. So they both decided to share this pair. They both decided to share this pair. So they share. So this oxygen shares this pair, and this also shares this pair. Now this oxygen molecule also gains 8 electron in total, and this also gains 8 electron in total. So this molecule becomes highly stable. Okay, formation of triple compound bond in nitrogen molecule. Nitrogen molecule is also an example of covalent compound. It is same as O2 molecule. Okay, we don't need to read about whole para. You can read this. I'm simply going to tell you how nitrogen forms triple bond. See, nitrogen has 7 electrons. Its electronic configuration is 2, 5. It has 5 electrons in its valence shell. It only needs 3 electrons to get stability. Okay, so this nitrogen needs 3 electrons. This also needs 3 electrons. Okay, so this nitrogen decided to do like this, and we expand this also, this like this also. So they both get 8 electrons. Count it. 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen has 8 electrons. This also has 8 electrons. So 1, 2, 3. Triple bond is formed like this. N2 molecule is formed. Now move to next slide. See how hydrogen molecule is formed. One hydrogen, both has 1 electrons. So this hydrogen molecule is formed. See, electron comes in between of the both hydrogen. See, this is nucleus of both the hydrogen atom. Electrons come in between of both the nucleus of the hydrogen. Now in fluorine also, fluorine has atomic number 9, and let's see its electronic configuration. Its electronic configuration is 2, 7. Fluorine only needs 1 electron to gain stability. Okay, so it just needs 1 electron. So this electron and this electron is shared between them. So the shared pair comes in between the nucleus of both the fluorine atoms. Okay, fluorine molecule. Now oxygen molecule. Oxygen need only 2 electrons. So the shared pair comes in between. Oh, see, sorry. This is carbon dioxide molecule. Carbon is in between and oxygen is here. Okay, carbon has 4 electrons. 1, 2, 3, 4. It needs 4 electrons to get stability. Okay, and here is 2 oxygen molecule. Draw oxygen molecule here and here. Place the carbon in between the 2 oxygen molecule. See, this oxygen needs only 2 electrons. Carbon has 2 electrons. Draw the structure like this. Okay, oxygen needs 2 electrons. Carbon has 2 electrons left, and oxygen also has 2 electrons. So CO2 molecule is formed. Now see fluorine atoms. We are going to see carbon tetrafluoride. There are 4 fluorine atoms, so it needs 4 electrons. There is 1 carbon atom and it needs 4 electrons. So these electrons are shared between 4 carbon atoms. Okay, sorry. So carbon is placed in between of the 4 atoms, and the carbon is surrounded by 4 fluorine molecules. 1, 2, 3, 4, and each fluorine only needs 1 electron, and carbon also has carbon needs 4 electrons. So this fluorine only needs 1 electron. So here it is. This fluorine only needs 1 electron. Here it is 1, 1. So this type. So now this way the molecule is formed. Got it? Sorry. Now see the electron dot structure. Methane molecule CH4. CH4 is an example of electron dot structure. In electron dot structure, we basically represent electrons in the form of dot. In electron dot structure, we basically represent electron in the form of dot. Okay, see, here is CH4. In the previous slide, I have told you how CH4. No, I have told you how carbon tetrafluoride is formed. Now we are going to study how CH4 molecule is formed. See here, carbon atom is here and carbon has 4 electrons. Let's say carbon electron is represented by cross. Carbon electron is represented by cross and hydrogen electron by dot. Okay, so hydrogen has 1 electron and it only needs 1 electron. So it is shared like this. It is shared like this. Okay. Now I'm going to represent in a better way. Carbon has, see, it has 4 electrons and we have 4 hydrogen atoms. 1, 2, 3, 4. To satisfy both the valencies of hydrogen and carbon, we can do like this. So we can simply make like this. Okay, and carbon needs 4 electrons, so all the 4 electrons of the hydrogen are shared like this. So carbon gets 8 electrons and hydrogen each gets 2 electrons. So this becomes a stable entity. Similarly for C2H4 also. See, C2H4, 2 carbons are placed like this. Make carbon electrons from cross. All the carbon electrons from cross. And for satisfying carbon valency, we will satisfy from hydrogen. Okay, so hydrogen, hydrogen, hydrogen. So each hydrogen satisfies its valency like this. See, this. It has this. Okay, and this carbon. See, here is 1 electron. Also, carbon has 1 electron, and it will be shared between both the carbon atoms. So one bond will be formed in between them. So it is shared like this, and carbon stable and carbon stable. Okay, let here it is like this. So now you can easily see the representation drawn by me. Okay, you can easily see the representation here, and if we are going to represent it through bond, electrons are represented. 2 electrons form one bond. 2 electrons form one bond. This bond is like this, like carbon hydrogen, one bond, one bond, one bond, one bond. This is called sigma bond. Okay, for sigma, pi, triple bond you will study in further classes also. So don't worry about this. Just learn the tricks and things in step-by-step process. Okay, so I'm going to end this chapter here, and rest of the slides will continue tomorrow. Okay, see you guys tomorrow. Thank you so much. If you like my content, so you can subscribe to my channel. If you like really, you can also hit the like button. Thank you so much, guys.